Okay, so in this video, I'm just going to make a video about practicing the same type of problem. So hopefully the more you do these, the more you get with them. You can just look up these, how to solve these, look for videos, just practice more problems, and hopefully you'll understand better. But just the more practice you get, the better you are with them. Rewrite number one as a logarithm. So we just take the log, the base stays the same, and then whatever's on the same side no longer goes on the same side, right? So you can look those up, how to go between exponential form and logarithmic form, right? So the next one isn't a log. I basically want to write it as an exponent. So 4 raised to what? That's what the log is saying. 4 raised to what is 1024. So I just figure out 4 times itself how many times to get to 1024, right? So I take 4, just keep on multiplying 4 by itself until you get to 1024, right? So take 4 times itself 5 different times, and you will get 1024. So that means my x equals 5, or this equals 5. Okay. All right, next one. I know the graphing is sometimes hard. So you find your asymptote, which is the line that it doesn't cross, even though it looks like it's crossing that one. So x equals 0 is the asymptote. I go 1 over. Now these are counting by 2, so I only want to go 1 over. So I'm going right here. And then I see, where does my graph hit this kind of line right here, right? It hits it right here at this value, which is right in the middle between 6 and 4, so that'd be 5. So k equals 5. So I go just 1 over to the right, and then I go up and see what's the y value that hits my graph. So 1 to the right of the asymptote. Okay. Then this one's, I have 2 different ones. Here I have this one, which is g of x, and it wants me to tell what the end behavior is. So as I go more and more to the right, this graph keeps on going down. So as x goes to infinity, g of x is going down. Right now, as I go from right to left, as I approach this asymptote right here, x equals 0, I'm always approaching the asymptote. This asymptote for this problem is 0, right? Because that's the line that's not crossing. As I go that way, my y value just keeps on going up. So as we can see the arrow, it just keeps going up and up and up. So my g of x goes up and up and up. Okay, now the f of x is a different equation, right? So here I want to find the asymptote for that. So I'm using this formula, a times log of my base of x minus h. So that x minus h is in parentheses. It's what I'm taking the log of, and then I'm adding some value c at the end. So this one I have no parentheses, so it's just the x right there. So what makes that 0? What makes that 0 is when x equals 0. So that would be my asymptote. X equals 0. Because what's make the log 0? So it's the same. It shares the same asymptote right here. Okay. So that means as x goes to my asymptote 0 for this problem. Now I figure out, okay, now which direction is it going? Is it looking like g of x here? Is it looking like g of x, or is it a different equation, right? So here I can plug in a number like 1 for my x, and then I can think about that problem that I did above, log 10 of 1. That means 10 to the what equals 1? Well, that would be 0. So I know that when my x is 0, my answer to this will be 1. So at 0, I'll be up here at, sorry, mix those up, as 10 to the 0 is 1. Okay, so that means when I'm over 1, so I go over 1, I'd be up at 0. So I'm actually right here at this point right here, 1, 0. So it's backwards of the log. So this would be my actual x value, and this is my y value, not the other way around. Okay, so that's when you just try to say, what do I have to plug in for x to make it be 1? And when x is 1, the answer of the log is 0. Okay, now I find another point. I always want to match my base. So my base is 10, so I want to put what gets me to plug in 10. That would be 10. And whenever I take log base of that same number, it's always going to equal 1. So that means when I plug in 10, I'll get 1. So there's my graph of the second one. So as I go to the right, increasing, my graph continues to go up. F of x goes up. Now as I go to the left, the right, I approach that asymptote, right? That asymptote right through here, and then I go down. So as I approach the asymptote, my y value goes down towards negative infinity. Okay, more graphing. If I'm asked to graph this, now listen, if you look, the difference between these two, this one right here doesn't have a parentheses, right? It's just x. This one has a parentheses, so that means I am taking the log of x minus 4. So that means I have to know, what do I plug in for x, that when I subtract 4, I get 0, and that is 4. That means that is my asymptote. So at x equals 4, I have an asymptote. That is my h value. What do I plug in for x that makes what I'm taking the log of 0? Now, am I adding anything to this outside the parentheses? No. So that means my k is 0. Am I multiplying anything by the log? No. So that means my a is 1, right? So if I multiply by 1, everything stays the same. But if I multiply by 0, the whole thing would be 0. So my a is 1. And now I have everything that I need except for my base. My base is lower subscript there is 2. All right, so now I can graph, and I can always graph this way. My h plus 1 comma my k. Well, my h is 4, so 4 plus 1 is 5. My k is 0, so 5, 0. I have that point 5, 0, 5, 0. Okay, now my second point is b plus h, and then it's a plus k, because I want my base, right? So what's going to get me to my base? So if I plug in 6, right, 6 is 4 plus 2, right? Because I want log of 2 because I know that answers 1. So if I plug in 6, and for this x, I would get 2, and log base 2 of 2 is 1. So if I plug in 6, I would get 1. What's 1 times 1? 1. 1 plus 0 is 1. So over at 6, I'm up at 1. So then my graph would look like this, going up and then goes down, approaching the asymptote. Okay. All right, next page. Okay, this one, just rewrite an exponential. 64 raised to the 5/3, and I'll remember, raising to the 5/3, a third power is like a root. It's a cube root, meaning what times itself 3 times is 64. So what cubed is 64? And that answer is 4. So this is 4. Now I have a power on top of 5, so I want to take 4 to the 5th. So that means 4 to the 5th, we already found that out from the other one, right, is 1,024. Okay, this one's a little bit different. We have same base. We're going to set these equal to each other. So 3x equals x squared minus 10. So I'm going to subtract 3x on both sides to get 0 equals, because it's quadratic, 3x minus 10. Now I can try to factor it and use CAB. So I get c times a is negative 10, my b is negative 3. So what times what is negative 10 but subtracts the 3? So that'd be negative 5 and a positive 2, right? And then x minus 5 and x plus 2 equals 0. So that means x equals 5 and x equals negative 2. But I can't plug a negative 2 in here, and I'd take a log of a negative. Can't have that. So I can only get rid of only half the 5. Now approximations, we're having trouble with this a little bit, so I want to break down. Oh man, that probably should just be 2 there. Dang it. So that should just be 2. Sorry about that. All right, so now I want to break this down by taking 24 and dividing it by 3 and see how many times 24 or 3 goes into 24. So once, it doesn't work again, right? So I can rewrite this log base 2 of 24 as log base 2 of 3 plus log base 2 of 8, because I broke down the 24 to 3 times 8. Now I can break down this, because 2 cubed is 8, right? So I can erase this 8 and write 2 cubed. So then I can bring log base 2 of 3 plus 3 log base 2 of 2. And we already know this from before, that log of a base of that same base is always 1, right? So that will equal 1. 3 times 1 is 3. 3 plus this number is right here. So 3 plus 1.58 is just 4.58. And that would be my answer. Okay, moving forward. Here we have a pH level of pineapple juice. I just made that up. So I set pH equal to log base 10 of 1 over h plus. Now I can go ahead and write this as an exponential. 10 raised to 3.4 equals 1 over h plus. I can make a fraction of this by putting 1 on the bottom. Then I can just flip both fractions. So 1 over 10 raised to 3.4. So then I'm just going to take on a calculator, 1 over 10 raised to 3.4 and see what that answer is. Raise it to, or round it to the 10,000ths place. Okay, this one, I'm just going to take the log of both sides because I can't turn 7 and 17 in the same base. Now, if you notice about this one, I only have an x on this part, right? So I'm going to bring 2x out front. So this is all multiplication, multiplying here, multiplying here. So I don't need to add or subtract anything or distribute anything or move anything to the other side because I have x on the left. That's all I need. X is by itself on the left. So now I just divide by what's next x, what is not x, because this is all just multiplication. So I'm going to divide by 2 log 7 because that's not x. So then x is equal to log 17 over 2 log 7. So hopefully these help. Just extra practice. Same with this one. Take the log of both sides, or even somebody rewrote this on the quiz, log 14 of 79 equals x, which is great, but then use change of base formula and rewrite it as log of the top, 79, over log of the base, 14. That's fine too. Okay, or you can take the log of both sides. So log 14x, log of the other side, bring the x in front, and then just divide by what's not x, because I only have one x. These are the best type of problems. So you can see I get the same exact thing. Log 79 over log 14. And then you just plug that into the calculator for this second part, right? Make sure you close off this divided by closing off this one, right? And then hit enter. All right, so that's the first part of the quiz, right? Second part of the quiz, same type of thing here. I just have an inequality, right? So I'm going to take log of both sides or ln of both sides. It really actually doesn't matter. Now this one I do have, my 4's are going to look like y's. I apologize, but just the way it is. Okay, so I take the log of both sides, which I didn't do that. Now, because my exponents have 2 y's in them, it's a lot more work, and this one has 2 terms. So again, when I rewrite these, I'll bring the exponents out front. So 4y log 3, log 3 less than y plus 7. Because there's 2 terms, I'm going to put that in parentheses, but only because there's 2 terms. Now I distribute that, and I get y log 4 plus 7 log 4. And now, because again, I have 2 y's, one on each side, I'm going to move my y's to one side. So over here, I have a y, so I want to move this y over. So 4y log 3 minus y log 4 less than 7 log 4. Now I'm going to factor out a y. So I'm going to bring out a y on the outside, and I get left with log 3 minus log 4 less than 7 log 4. So now I can divide by what's not log, right? I'm going to divide by log 3 minus log 4. And this is only true because I have it on both sides. That is the only reason I'm distributing here, up here, and that's the only reason that I'm subtracting. It's because I have 2 y's on both sides. 7 log 4 over log 3 minus log 4. Okay, done. Okay, next one, I'm just using change of base formula. So log of the top over log of the bottom, plug that in, see what you get. This one is a little more work, but I want to leave it as log x, so I'm going to use change of base formula. So first of all, I need to get the log by itself, so I'm going to add 5 to both sides, and I get 28 equals 14 log 8 of x. So I divide by 14, so I get 2. So I get 2 equals log base x, or base 8 of x. Now I want to use change base formula. So I'm going to come over here, use change base, and 2 equals log of x over log of 8. So I'm going to multiply both sides by log of 8. This will cancel out. Multiply this side by log of 8. I'm not taking 8 times 2 because log of 8 is a different number than 8. Okay, so I just put the 2 in front of the log. And that equals log of x. So there's my answer. That's in terms of log of x. Log of x equals. Okay, this next one, we're rewriting these, switching from exponential form to logarithm, but we got a base of e, so that means we're going to do ln, right? So I just take ln of both sides. Ln of 2x equals ln of e to the 21. Well, ln of e raised to 21, that 21 is going to move out front. So it'll look like this. And ln of e is just log base e of e, which equals 1. So that's going to equal 1, so it's going to go away. Okay, we can do that to these ones. So ln of 21 equals 2x. Switch this one, switch to exponential form. So base e, so e raised to 18 equals 31x. This would be e raised to 31x equals 18, right? Because ln is just log base e of 18 equals 31x. Switch to exponential form. E raised to this equals that, right? Okay, this one, put it in one single log. Same rules apply. I can take multiplication, I can bring it back as an exponent. So ln of 25 raised to the 1/2. A 1/2 power is a square root. So that would equal 5. So this turns to ln of 5 minus ln of 20 plus ln of 16. Now, whenever you're adding, subtracting logs, whenever you're adding them, you're really multiplying what you're taking the log of. And then if you're subtracting, you are going to divide by what you're taking the log of. So it's really ln of 5 times 16 over 20. So that is going to be ln of 80 over 20, which is ln of 4. So my answer is ln of 4. That's one single log. Okay, last couple. I want to figure out, I'm starting with 200 grams. Here's my function. Here's my k value. I'm really just using a pert, or I'm using y equals a e raised to kt. Same thing. Okay, I want to figure out when do I get down from 200, starting at 200 to 120. So I want to get down to 120 after so many years, right? When I start out with 200, and here's my rate. So I want to solve for t. So that means I'm going to divide 120 by 200. And then I'm going to take the ln of both sides. And then I'm going to divide by my k. So I'm going to type that into my calculator and see what do I get. So ln of 120 over 200, close that parenthesis off, and then divide by negative 0.4. And I'm going to round 1.277. So approximately, so a little after an hour, right? So there's my t, okay? All right, next problem. These last two or last three are kind of the same, or I guess 18 is a little bit different. Okay, solving this one, we want to get, just like that one problem, we had to get the log by itself, so I want to get the ln by itself. So I want to multiply by -5 on both sides and divide by 7 on both sides. So which is really multiplying by the reciprocal, right? The 5s are going to cancel out, the -7s would cancel out, or the -5s, however you want to deal with it. Okay, so that's going to be -25 over 28 equals ln of 2x minus 10. Ln of 2x minus 10, not 20. Okay, so then now I can switch to exponential form, right? So e raised to the fraction -25 over 28 equals 2x minus 10. So then I'm going to add 10 to both sides. 25 over 28 plus 10 equals 2x, and then I'm just going to divide by 2. So let's figure out what that is. Did divide by 2. Oh. All right, I'm going to type it. Okay, so I get x is equal to 5.2047. Round to the thousandth, so that'd be 5.205. Okay, next one. I want to solve for k. I want to find out the growth rate. That's finding k, so I'm really using this. Kind of running out of time here. Y equals AEKT. So I want to solve for k, so k is equal to ln of y over a divided by t. So I know in 1990 we got $1, so that'd be the beginning amount, right? And I know in 2015, so that would be, 25 years later, the amount is now $5,000, right? Okay, so then I can solve this by taking my ln of y over my a, over my a, switch those, so y over 1 is just going to be 5,000, right? Over my years, and that will be my k value. So if I do that, so I take, let's get to the bottom of this. All right, so I take alpha link, I do ln of a fraction, or I don't really need a fraction, just ln of 5,000 over 25. So that's not a decimal there, it's just one. Okay, and so I'm going to round to the thousands for my k. So my k is equal to 0.341 if I round it. Okay, now I want to use that to write my equation. So it's going to be y equals 1e. So I really don't need the 1 there, but I'll put it in there. E to my k, which is 0.341, and then times by t. So that's my equation. Now I can predict it to what? Year. So to do the year, when I want to reach 12,000, so I want to know when is it going to be 12,000 when my k is 0.341. I want to know the year, right? So I'm going to do the same equation, ln. I'm just going to switch the k and the t here. So ln of 12,000 over 1, which is just 12,000. And then this time I'm going to divide by my k, which is 0.341. And that's going to give me my t. So let's change that up again. So 0.341 for my k, and then 12,000 divided by 1 is 12,000. So take the ln of that. And we get about 27 years later, 27 and a half years, so 27.5 years later. So that would be, since 1990, that would be 2000. Well, it's grown fast, right? So, because this was 25 years later, this is 27 years later, so only 2018, by 2018, right, if I round up, it would be at $12,000. Okay, same thing a little bit here. Start out at 2010 with 30,000. In 2015, it reduces down to 12. So this is going to be a negative k. So I take my ending amount, which is 12,000, divide it by my beginning amount, which is 30,000, and take the ln of that, and then divide by how many years, right? So that's only 5 years. So I do that. So ln and there's my k, so my k equals negative, because it's decreasing, it's a decay, 183, round to the thousandths. So then my equation is y equals 30,000, 2, 3, e raised to 0.1, it's a negative 0.183 t. Now I can predict the year that it reaches 4,000, so that'd be 12,000, or that'd be 4,000 over 30,000. Take the ln of that fraction divided by my k, which is now negative 0.183. So ln, I'm going to take 4,000 divided by my k, negative 0.183. And in about 11 years, so 11 years past 2010 is 2021. So 2021. So there you go. So there's some extra practice for you. So hopefully that helps. But the more you practice with these, the better that you do with them. So you can make up your own, just change the numbers, see how it goes, or you can search on YouTube for videos how to solve them, or use AI to create new problems for you.